Hello everyone, in this video we are going to learn about function. So what is a function? A function is a relation. If every element of set A has one and only one image in set B. A relation is said to be a function if every element of set A has one and only one image in set B. So if we write the same definition with respect to ordered pairs, no two distinct ordered pairs have same first element, then that is said to be a function. Let us check some examples of these functions. Okay. I have two sets, set A and set B. In the set A, we have 1, 2, 3, 4, 5, 6 elements. And in the set B also same elements again 1, 2, 3, 4, 5, 6. 1 is connected to 2, 2 is related to 3, 3 is related to 4, 4 is related to 5 and 5 is related to 6. Now let us check whether this is a function or not. So what exactly the function definition is saying? If every element of set A, from the set A, every element should have one and only one image in set B. Now let us check. For element 1, one image is there. For element 2, image is there. For element 3, image. For element 4, image. For element 5, image. But for element 6, no image is there in the set B. So this is not a function. Now let us take one more example. Okay, now I have two sets. One set is X and one set is Y. In the set X we have 6, minus 7 and 0. In the set Y 10, 3 plus 4 and minus 4 is there. 6 is related to 10 as well as 6 is also related to minus 4. 7 is related to 3 and 0 is related to 4. Now let us check whether this is a function or not. So the first condition, every element of the first set should have some image. 6 image is there, 7 image is there, 0 image is there. So for every element of the first set has an image. Next, what is the second condition? Every element of the first set should has one and only one image. Now if we take the first element 6, 6 has 10 as the image and the same 6 has minus 4 as the image. So the only element 6 has two images. But according to the definition of function, every element of the set 1 should has only one image, but here two images are there for the same element 6. So this is not a function. Now let us take one more. I have set A and one more set B. In the set A, I have minus 1, 0, 2, 3, 4 and in the set B 0, minus 3 and 5. Minus 1 is related to 0 and 0 is related to minus 3. 2 is related to minus 3 and 3 is also related to 0 and 4 is related to 5. Now let us check whether this is a function or not. So the first condition, every element of the first set should have some image. Minus 1 image is 0, 0 image is minus 3, 2 image is minus 3, 3 image is 0, 4 image is 5. So every element of the set A has image. Next, second condition, every element of the set A should has only one image. For minus 1 the image is 0, except that no other image is there for minus 1. Next, for 0 the image is minus 3, so except minus 3 no other image. For 2 minus 3 only one image. For 3 it is 0, only one image, no other image. For 4 image is 5, so only one image. So it is satisfying both the conditions, so then it is said to be a function. Okay, let us take one more example. Y is equals to 5x plus 1. Now we need to check whether the given equation is a function or not. So first I am substituting some numbers in the place of x. If x is equals to 1, if x is equals to 2, if x is equals to 3, and x is equals to 4. If you want, still you can take more numbers. Then what is the y value? What is the y value? Let us substitute the x value in the given equation and let us check now. In the place of x, I will substitute 1. 5 into 1 plus 1 as it is. 5 ones are 5 plus 1, 6. So y value is 6. I will write that 6 here. Next, substituting 2. 5 into 2 plus 1. 5 2s are 10 plus 1, 11. That 11 I am writing here. Next, substituting 3. 5 3s are 15 plus 1, 16. That 16 I am writing here. X is equals to 4. 5 times 4 plus 1. 5 4s are 20 plus 1, 21. Now, if we observe clearly, whenever we are substituting 1, we got answer 6. So that ordered pair we can write it as 1 comma 6. Next, substituted 2, we got 11. So that can be written as 2 comma 11. Next, substituted 3, we got 16. So that can be written as 3 comma 16. Substituted 4 and we got 21. So that can be written as 4 comma 21. Still you can substitute 5, 6, 7. You can check, no problem at all. Now, we need to check any element. I mean whatever we are substituting in the place of x. Does it have two images? For 1, only 6 is there, so one image only. For 2, 11, only one image. For 3, 16, only one image. For 4, 21, only one image. Every element of the first set has only one image. So this is a function. Okay, let us take one more example. Y square is equals to x plus 1. Now in the place of x I am substituting 1. If x is equals to 1, y square is equals to, in the place of x I am substituting 1. So 1 plus 1. Y square is equals to 1 plus 1, 2. Then y is equals to plus or minus root 2. Now if I am writing this in the form of circles, here x value whichever I am substituting, and here y value whatever I am getting I am writing. Now x I substituted plus 1. I got two values as y, that is plus or minus root 2. It means one value is plus 2 and one value is minus root 2. So for 1, plus root 2 will be answer, as well as minus root 2 also answer. So one element has two images, so that's why it is not a function. One element has two images, so it is not a function. In this case, no need to check the second element also. Okay, this is one of the methods to check whether the given relation is a function or not. And the second type to check whether the given relation is a function or not is vertical line test. That is vertical line test. So we have some figures. Now we need to find out that particular figure represents a function or a not. So anywhere on that curve or line on that figure, draw one vertical line. I am drawing one vertical line. Anywhere you can draw, that is your wish. Now if that particular vertical line is touching the curve at 2 points, this vertical line is touching this curve at only 1 point. This vertical line is touching the curve at 2 points, and this vertical line is touching that straight line at only 1 point. If it is touching at only 1 point, it is a function. If it is touching at only 1 point, it is a function. If it is touching at more than 1 point, it is not a function. Not only circular shaped figure, square, rectangle also not functions. Okay, now let us discuss about types of functions. Types of functions. The first type of function is one function. One function. So one function means each element in the domain has distinct image. Let us check once. We have a function f of x is equals to 3x plus 5. No need to get confusion for this f of x. Function in terms of variable x. F of x is equals to 3x plus 5. The same f of x we can replace with y also. Y is equals to 3x plus 5. Now I am taking two sets. One set is for input and one set for output, that is x and y. Now x, I am taking some numbers, that is 0, 1, 2, 3. Now what we will get for y? In the place of x, first I will substitute 0. 3 into 0 plus 5. 3 into 0, 0. 0 plus 5, 5. So we got output as 5. Next, I will substitute 1. 3 into 1 plus 5. 3 ones are 3 plus 5, 8. So I got the output as 8. Next for 2, 3 into 2, 6 plus 5, 11. Next 3 into 3, 9 plus 5, 14. So for 2, I got the output as 11. Input if we give as 3, we got output as 14. Now, each element in the domain. This domain is nothing but the first set. Each element in the domain has a distinct image, nothing but exactly one element from the set A should has only one image, one function, one element only one image, one element only one image. This is one function. Next type of function is many one function. Okay, the next function is many one function. Many one function means at least two elements in the domain should have same image. Let us check this. I am taking one function f of x is equals to x square plus 1. So this f of x I am replacing with y. Y is equals to x square plus 1. Now I am taking two circles, one is for input and one is for output. This is for a small x I am taking and this is for small y I am taking. Now in the place of x, I will substitute some numbers. I am substituting 0, then minus 1, then plus 1. Now for 0, if we are substituting, what we are getting? If we are substituting -1, what we are getting? If we substitute +1, and what we are getting? Let us check now. In the place of x, I will substitute 0. 0 square plus 1. 0 square is 0. 0 plus 1. 1. So if we are substituting 0, we are getting output as 1. Next, -1. In the place of x, I am substituting -1. -1 square plus 1. -1 square plus 1. Already plus 1 is there again. Plus 1 plus 1 plus 2. Now I will substitute plus 1. In the place of x, plus 1. 1 square plus 1. 1 square, 1 plus 1. 1 plus 1, 2. Now if we observe this, these two elements from the set A has the same image 2. So -1, 2 as well as +1, 2. Two elements from the set A has the same image. So this type of function is called as many one. So it means many elements has one image. Many elements has one image. Many one. Okay, the next type of function is many one function. Many one function. So many one function means at least two elements from the domain should have same images. So let us check this by taking one example. I am taking the function as f of x is equals to x square plus 1, and this f of x I am replacing with y. So y is equals to x square plus 1. So one is for input and one is for output. So in the place of x, first I am substituting 0. 0 square plus 1. 0 square 0. So 0 plus 1 is 1. If I am substituting 0, I got the image as 1. Next, in the place of x, I am substituting -1. -1 square plus 1. -1 square is 1. 1 plus 1, 2. So if I am substituting -1, I got the image as +2. Next, in the place of x, I am substituting +1. 1 square plus 1. 1 square 1 plus 1, 2. So if I am substituting +1, again I got the same image 2. So this exactly says more than one element from the set A has same image. Many elements from the set A has one image. Many one. This type of function is called as many one function. Okay, now let us discuss the next type of function. So before going to this type of function, let's revise once again what is domain, what is range, and what is codomain. This is for set A and set B. So in the set A we have 3 elements 1, 2, 3, and in the set B we have -1 and +2 and 4. Now this 1 is related to -1 and 2 is also related to -1 and 3 is related to 4. So now whatever the input we are giving, that is called as domain. Next, whatever the output we are getting, here -1 we got as well as 4 we got. So that -1, 4 is called as range. Next, total set B is called as codomain. Whatever the input we are getting, it is called as domain, and whatever the output we are getting, that is called as range, and total set B is called as codomain. Okay, now let us check the next type of function. Onto function. Onto function. Onto function is nothing but if range of a function is equal to the codomain of the function. So for example, we have two sets. set A and set B. In the set A you have x, y, w, z elements, and in the set B we have 1, 2, 3. X is connected to 1, y is also related to 1, w is related to 2, and z is related to 3. So okay, now for this function, what is the range? Range of this function is 1 is output, 2 is output, 3 is also output. So range of the function is 1 comma 2 comma 3. Next, what is the codomain of the function? Codomain is nothing but the total set B, that is 1 comma 2 comma 3 again. So in this case, range 1 comma 2 comma 3, codomain 1 comma 2 comma 3. So range is equals to codomain. Range is equals to codomain. Then this type of function is called as onto function. Let us check one more. Here I have set A with two elements 1, 2, and one more set B. I have only one element, that is W. Here 1 is related to W. Sorry, I will take one more also. V also I am taking. 2 is also related to W. Now check it here. Here the range is W, but codomain is V comma W. So in this case, range as well as codomain both are not equal. So this is not onto function. Okay, the next type of function is into function. Okay, I have a set A and I have a set B. Set A we have 1, 2, 3 elements, and set B we have 1, 2 elements. 1 is related to 1, 2 is also related to 1, and 3 is related to 2. Now here the range is 1 comma 2. Codomain is also 1 comma 2. So if the range is equals to codomain, already we discussed, that is onto function. In case if one more extra element is there in the set B, now here the range is 1 comma 2, but codomain is 1 comma 2 comma 3. In this case, range is not equal to codomain. If range is not equals to codomain, then that type of function is said to be into function. And next type of function is bijective function. Bijective function. A function is said to be bijective if it is 1 function as well as onto function. If a function is 1 function as well as onto function, then that type of function is said to be bijective function. Let us check once. I have set A and set B. In the set A we have A, B, C elements, and in the set B we have 1, 2, 3 elements. A is related to 1, B is related to 2, and C is related to 3. Every element of A has only one image. So this is 1 function. Next, range is 1 comma 2 comma 3. Codomain is 1 comma 2 comma 3. Range is equals to codomain, then it is onto function. Now this is 1 function as well as onto function, so then it is bijective. Okay, the next function is inverse function. Inverse function. So we have one function f is equals to, the ordered pairs are given as 1 comma A, 2 comma D, 3 comma B, and 4 comma C. So now for this given function, he is asking to write the inverse. Inverse is nothing but f power minus 1. F power minus 1 is said to be inverse function. Then simply interchange the elements. Second element you write to first element to write second. So 1 comma a can be written as a comma 1. 2 comma D can be written as D comma 2. 3 comma B can be written as B comma 3. 4 comma C can be written as C comma 4. So this is the inverse function. Okay, instead of giving the ordered pairs, he gave equation. Then how to solve that equation? How to find inverse of any given equation? Let us check once. Okay, the function is given as f of x is equals to 2x plus 3. Now find the inverse of this function. So first f of x you take it as y. So y is equals to 2x plus 3. Now swap the variables. Swapping the variables. X will come here, so x is equals to 2 into y will come in the place of x plus 3. Now find the value of y. So plus 3 I am taking to another side, it will become minus 3. So x minus 3 is equals to 2y. We want y value, so take 2 also this side. X minus 3 by 2 is equals to y. Now this y you replace with f inverse x. F inverse of x is equals to x minus 3 by 2. This is the inverse of this function. So it is very simple. F of x is equals to 2x plus 3 is given. First f of x you take it as y. Then y and x you both swap. X you write here, y you take there. So we will get x is equals to 2y plus 3. Now you find the equation for y. So take plus 3, this side will become minus 3. Now send 2 also, this side will become divided by 2. So this is the inverse of the function. Now let us check one more. F of x is equals to x square plus 8. First replace f of x, y is equals to x square plus 8. Now swap x and y. Here x is equals to y square plus 8. Now we want equation for y, so bring 8 this side. X minus 8 is equals to y square. Y square value is x minus 8. Then y value will be under root x minus 8. Okay, so y square is x minus 8, then y is equals to plus or minus under root x minus 8. Here only most of us will do mistake. We won't write plus or minus, simply we will write under root x minus 8. So we should not do like that. Now plus or minus under root x minus 8 means one value is plus x minus 8. One value is minus under root x minus 8. So two images are there. So it means inverse won't be there. No inverse. Okay, let us check one more example. F of x is equals to 3x plus 2 divided by x minus 1. Find the inverse. First, for f of x we need to write y. So y is equals to 3x plus 2 divided by x minus 1. Now swap the x and y. In the place of y x, in the place of x y. 3y plus 2 divided by y minus 1. This total denominator y minus 1 I am taking to the left side. So we will get x into y minus 1 is equals to 3y plus 2. Now I am opening this bracket, x into y, xy minus x into 1, x is equals to 3y plus 2. Now I am bringing this 3y this side and taking minus x to that side. xy plus 3y will become minus 3y minus x will become plus x plus 2. Now from these two I am taking y common, so remains with x minus 3 which is equals to x plus 2. We want y equation, so y is equals to x plus 2 divided by x minus 3. Now this y you substitute with f inverse of x, which is equals to x plus 2 divided by x minus 3. Okay, let us take one more example. F of x is equals to x square. So f of x, first I am replacing with y, so y is equals to x square. Now swapping the letters, x is equals to y square, then y is equals to plus or minus under root x. Plus or minus root x is nothing but plus root x and minus root x. So two images are possible, so no inverse at all. Okay, now let us discuss some more types of functions, that is identity function. Identity function is nothing but f of x is equals to x. So f of x can be written as y, so y is equals to x. In the place of x, if I substitute 0, y value also 0. If I substitute 1, y value also 1. If I substitute 2, y value also 2. If I substitute minus 1, y value also minus 1. So this type of function is called as identity function, where the two elements in the ordered pair are same. So if we draw the graph for this kind of identity function, it passes through the origin, because 0 comma 0 is there, so 0 comma 0 is nothing but origin. Next type of function is linear function. This linear function is nothing but f of x is equals to mx plus c. F of x is nothing but y, so y is equals to mx plus c. Now for easy explanation, I am taking some value. Y is equals to m, I am taking as some 3x plus constant I am taking as some 4. So y is equals to 3x plus 4. This kind of equations are called as linear equation. Linear is nothing but the degree of the equation is 1. For x the power is 1, for y the power is 1. So the maximum power is 1. If the power is 1, it is said to be linear. Now if we draw the graph of this kind of equations, it will go like this. And what is the constant here? That point will be here exactly. What is the constant here? That is 4. So that straight line which we are drawing for the given equation, it touches the y-axis at 4. Okay, next one is absolute value. Now this absolute value is nothing but, for example, f of x is equals to modulus x. F of x I replace with y, so y is equals to mod x. Now in the place of x I am taking minus 1. So what we will get? Mod minus 1. Mod minus 1 is nothing but plus 1. So minus 1 comma 1. Now I am taking 1 in the place of x. 1 comma mod plus 1 plus 1. Now I am taking minus 2 in the place of x. Mod minus 2 plus 2. I am taking x value as 2. So mod plus 2 plus 2. If we are applying mod, otherwise absolute value, always the value will be positive only, no negative at all. So if you are substituting minus 1 also, mod minus 1 will be plus 1 only. If you are substituting minus 2, mod minus 2 plus 2 only. If you are substituting plus 2 also, mod plus 2 is plus 2 only again. Now if we draw the graph for this absolute valued function, we will get a straight line and again like this. This is absolute value function. Next is constant function. This constant function is nothing but the constant itself, graph of the constant. Simply we can say f of x is equals to some constant. See, f of x I am replacing with y, and constant also I am taking some number 4. So now this kind of function, if we draw the graph, this is y is equals to 4. So on the y axis this is 0, 1, 2, 3, 4. So point will be here. If we draw one straight line, that is y is equals to 4. This type of function is called as constant function. Okay, next one is equal functions. Equal function is nothing but for both functions should have two functions, or both functions should have same domain and codomain. Same domain and codomain. Let us take one example and let us check once. F of x is one function which is equals to modulus x. Next, g of x is one more function which is represented as root x square. So we have two functions, one is f of x and g of x. F of x is written as modulus x and g of x as under root x square. So if these two are having the same domain and codomain, then these are said to be equal functions, right? Let us check once now. Now for this f of x, I am taking this as y is equals to mod x. So in the place of x, I am substituting minus 1. Modulus minus 1 plus 1. Now I am substituting minus 2. Modulus minus 2 plus 2. Now same domain, that is minus 1 and minus 2, I will substitute in this function also. G of x I am substituting with y. So y is equals to under root x square. Now in the place of x I am substituting minus 1. So under root minus 1 square, under root minus 1 square plus 1, under root 1 plus 1. I substituted minus 1, I got plus 1. I substituted minus 1, I got plus 1. Next, I will substitute minus 2. Under root minus 2 whole square is equals to under root minus 2 whole square plus 4, under root 4 2. I substituted minus 2 and I got plus 2. Minus 1 plus 1, minus 1 plus 1, minus 2 plus 2, minus 2 plus 2. So these kind of functions are equal functions, where the domain as well as codomain of both the functions are equal to each other. Now let us take one more example. I have a function f of x is equals to x square plus 2, and second function g of x is equals to 3x. Now first for this f of x I am taking as y. So y is equals to x square plus 2. In the place of x I am substituting 1. So what we will get then? 1 square plus 2. 1 square 1. 1 plus 2 3. So I substituted 1, I got 3. Next I am substituting 2. I am substituting 2. 2 square. 2 square plus 2. 2 square 4. 4 plus 2 6. I substituted 2 and I got 6. Now let us check the same for g of x also. I am checking the same for g of x. First I am substituting 1. 3 into 1 3. I am substituting 2. 3 into 2, 6. Here 1 3, here 1 3, here 2 6, here 2 6. So these two functions have the same domain and codomain. Then what about the negative number? Let us check that negative number also then. In the place of x, I am substituting minus 1. Minus 1 square plus 1. 1 plus 2, 3. If I am substituting minus 1, I got plus 3. Same minus 1 I will substitute here also. If I am substituting minus 1, 3 into minus 1, minus 3. Here I substituted minus 1, I got plus 3. Here I got substituted minus 1, but I got minus 3. Where the domain is equal, but codomain is not equal. So we can conclude that this is not an equal function. This is not an equal function. Okay, till now if you didn't subscribe to my channel, subscribe for more videos. Thank you.